The other application of the derivative that we'll look into is our linear approximations. So given the function f, a tangent at x equals a can be found. This. The equation of the tangent line is given by this is called the tangent line approximation or the linear approximation of the function. Because as you can see here, the function values are really close to the values of the tangent line. So somehow, the closer we are here, we can use the tangent line the tangent line values as an approximation or as an estimate of the values of the original function. So let's take a look at number 1. For example, we are asked to determine the linear approximation for f of x is equal to cube root of x at x equals 8. And we are asked to use that approximation to determine the value of cube root of 8.05 and the cube root of 25. So, first we have the function f of x is equal to the cube root of x. We want to find its linear approximation at x equals 8. So, the first thing that we need to do is we need to find the equation of the tangent line at x equals 8. So that means we need to find the derivative. So the derivative of our function cube root of x, the function can also be written as x raised to 1/3. This is the one that is easier to find its derivative. So the first derivative of this would be 1/3 of x raised to negative 2/3. Which would then be 1/3 x raised to 2/3. There. Rationalizing this by multiplying by x raised to 1/3, we're going to have x raised to 1/3 over 3x. So, if we want to find the slope of the tangent line at x equals 8, we need to find f prime of 8. Is 8 raised to 1/3 over 3 times 8, and we're going to have 1 over 12. So therefore, based again on our equation here, y is equal to f of 8 plus f prime of 8 times x minus 8. So let's write it here. Y is equal to f of 8 plus f prime of 8 times x minus 8. So we know that f of 8, which is 8 raised to 1/3, that is 2. So placing it here, we're going to have y is equal to 2 plus 1 over 12 times x minus 8. Fixing this equation here, we're going to have y is equal to 2 plus 1 over 12x minus 8 over 12. Therefore, simplifying this, we're going to have the function y is equal to 1 over 12x plus 4/3. This equation here is the tangent line approximation or the linear approximation of the original function, f of x is equal to cube root of x. Meaning, if we would like to find the cube root of values close to x equals 8, we can use this function instead, because it's easier to solve if it's linear than its cube root. For example, if we would like to find the cube root of, or at least estimate the cube root of 8.05, what we need to do is estimate it here. So we're going to have 1, that's approximately 1 over 12 times 8.05 plus 4/3. Now, this will give us an approximate value of 2.0042 rounded up to 4 decimal places. Or exactly, this is exactly 481 over 240. Now, if we want to take the actual cube root of 8.05, so 8.05, that will be equal to 4 decimal places 2.0042 as well, which is a good approximation. However, if we are to find the cube root of 25 using this linear approximation, it might not that be accurate. Finding the linear approximation of 25, that's 1 over 12 times 25 plus 4 thirds. That will then give us a value of, this becomes 41 over 12, which is around 3.4167. The exact value of cube root of 25 in decimal form, if we look for it in the calculator, is 2.9240, which is pretty far from what we have here. That indicates that the linear approximation only works for the values close to where we find the tangent line. It doesn't work, or the farther your x values to the where the point of tangents is, of course, the farther the approximation would be. Now let's work with number 2. We are asked to find the linear approximation for y is equal to sine x at x equals 0. So with this, what we need to do is, again, we have the equation y is equal to f of a plus f prime of a times x minus a. In this case, a is equal to 0. So therefore, the first thing that we need to do is find the derivative, then the value of the derivative at a and f of a. So first, y prime will then be equal to cosine x. So therefore, f prime of 0 would be cosine 0 is equal to what? F of 0 is equal to sine 0, that would be equal to 0. So therefore, we're going to have now y is equal to 0 plus 1 times x minus 0, which becomes y is equal to x. Which would mean, if we are asked to find or to estimate some values at x equals 0, for example, we are asked to estimate sine of 0.01 using the tangent line approximation. This is actually just the same as 0.01, because using the tangent line approximation, y is equal to x. So this is equal to its x. And our third example, in number 3, we're asked to do the same tangent line approximation for f of x is equal to 1 plus sine x at the point 0, 1. As we know, at the point 0, 1, x is equal to 0. Quite similar to what we have above. So we're going to still have actually the same derivative, f prime of x will be equal to cosine x. Therefore, f prime of 0 will be equal to cosine 0, which is equal to 1. F of 0, on the other hand, becomes 1 plus sine 0, which is equal to 1. So in this case, our tangent line approximation is equal to y is equal to 1 plus 1 times x minus 0. So there. By the way, the f of 0 is equal to 1 is actually seen here also, but it follows. It's consistent with the function. So therefore, what we're going to have is equal to 1 plus x, or if we write it in slope-intercept form, y is equal to x plus 1. Which would mean, for example, we are asked to find what would be f of, say, f of 0.1, it would be approximately equal to 0.1 plus 1, which is 1.1. So therefore, 1 plus sine of 0.1 is approximately 1.1. And those are examples of linear approximations.